Hi everyone. Okay, so this is continuing with the second video on the position dimension series. I've got my grid in place. It's 10mm grid spacing, and then the X and the Y axes. That's the X1 and that's the Y are highlighted in orange. So I'm going to draw an acute triangle, which means that doesn't have any equal. Every side is unequal. Okay, then I'm going to dimension this base, and you'll see that's a nice round dimension. The only reason I'm using the grid is just to simplify the dimensioning and speed things up. So you might be tempted from here to do this. Okay, just pull these dimensions out, and you'll see it goes black, so it's fully defined, and you think, okie dokie, cool. Not cool at all, because you or whoever's going to read the drawing that you're going to make from this has no way of establishing what this triangle actually is, the size, without using trigonometry. So you're going to have to ask them to do trigonometric functions. It's one of the derived ones, secant or cosecant, I forget which one, but you're going to have to do a ratio of 36 to 42 to 50 to get these angles, right? So your 50 is fine, that's all cool. The better way to do it, and the correct way to do an acute triangle, to dimension it, is to give it a base, which we've got already, and a height. All right, so let's go from that line to there. All right, and the only other thing we need now is to just position that point there relative to the starting point. So either directly or via some other point, that one or that one. So let me just show you the difference between those two approaches. One is that's 10mm away from the starting point. What that means is that 10mm dimension will keep that point in place, so that if I move this dimension, for instance, the proportions of the triangle change. If you don't want them to change, then we just need to reposition this dimension to that point, so that now I'm fixing the proportions of the triangle. And if I do decide to move it around for some reason or other, which is the whole point of dimensioning, is to be able to control what you're doing. Control Z. It'll stay fixed. Okay, so that's the way you do it. Now, in real life, you're going to have something slightly different to this, because whatever you make, you're always going to have fillets or chamfers or some way. Very, very seldom are you going to have sharp points. One, because they're difficult to make, and two, because they are dangerous. So let's put some fillets in here of 4mm. In fact, let's just go back to those dimensions and then do the fillets, because I want to show you what SolidWorks does for you if you start off with your dimensions of the outer shape first and then just add the fillets in afterwards. I mean, typically you'd put these fillets in the 3D model, not in the sketch, although, well, yeah, it's a better way of doing things. But regardless, what you're really doing with any kind of shape where you're putting fillets in is you're creating the outside shape, and then you are removing part of it. Or if you're creating a toolpath, you're saying, well, here's what the toolpath should follow as an outside shape. And then if that's, obviously that would be some kind of tool cutter which has a round shape. Not going to be able to do it, but you get the picture. So what SolidWorks does is it puts these virtual sharps in. These are called virtual sharps, and they trace these lines there. So they take what is the intersection of that line and that line, and so it reestablishes the triangle. If I remove these, to illustrate what you might do is you might draw this shape and say, okay, let's dimension this, and then commit the greatest crime in dimensioning law, which is to dimension a line segment. At least in my rules, although everyone else I've seen also doesn't like this. This is of little use to anyone because, let's put this last one in place, because you're asking whoever looks at this drawing, might be yourself, to do a whole lot of extra work. What you're essentially asking them to do is to reconstruct the triangle using these 3 dimensions. I'll show you how that works. So you're saying project a new triangle inwards by 4 millimeters, and I'll show you that this triangle is the same as what you're asking them to do, because look at that, that's 23.7, and that one there is 27.8, and if I do this one as well, it'll be right. So that's basically the idea, and then you're going to ask them to offset that one there, this whole triangle, by 4 millimeters, so that you end up back with the starting point which I just showed you. And then, so I'm going to delete that. So these are not good. Please do not dimension 2 line segments. You're going to lose marks. You're going to raise my blood pressure. The way to do this, if you've drawn something like this and you've forgotten to put the dimensions in at first, is you can re-establish the virtual sharps by using the point command. What you do is you hold the control button down, select a line, select another line, and then click on the point. There we go, there's a virtual sharp. Let's do that again 2 more times. 1, 2, virtual sharp, and the last one. With the virtual sharps in place, you can now dimension the real triangle, the original triangle. Okay, with position and size dimension, so that's a size dimension, and this one here would be also a size dimension. The height. Okay, actually these are all size dimensions, and then we would want 2 position dimensions, so it would be that one. Oh, we've got that one in place already. Let's do that again. Brain fog. There. Okay, there we go. So we can just delete that one there. All right, so that's the way that you would dimension it, and this, you'll do the same thing in the drawing. I mean, you can introduce these virtual sharps inside the drawing as well. If you have put a fillet anywhere and you want to dimension the original shape that it was derived from, that's how you do it. Thanks for watching. Cheers.